on with our managing nitrogen as a system, we're going to talk a little bit today about monitoring the N status of the soil. So we've heard the old saying many times, start right to finish well, and I think that applies here as well. The efforts we make in between the start and finish, however, will contribute to how well we position ourselves across that finish line. It's important to have an adequate supply of nitrogen at critical growth stages. So making an effort to understand and monitor the impacts of the N supply may give us some insight to keep that supply around when it's needed. So understanding the avenues of losses is one thing we're going to look at here shortly. So we're going to talk about the three main ones: leaching, immobilization, and denitrification. So today let's talk about leaching. The only form of N that can be lost from the soil is nitrate. So depending on what form of N was applied and when it was applied will determine the leaching potential. So it's a question of how quickly does ammonium N convert to nitrate. Rainfall, duration, amount, and intensity, rate of water movement through the soil. It's the rate of water movement through the soil, not necessarily how much rain you get, that determines leaching. And of course, the growth stage of the crop is a consideration. The initial moisture content of the soil, if the soil is already dry, then it's going to hold a little more water before it starts to leach. Soil organic matter certainly helps soils hold on to more water. Every inch of every 1% of organic matter allows you to hold an inch more water. Soil texture, obviously sandy soils are more prone to leaching. But leaching is not an efficient process. The landscape positions and attributes in the field contribute to it greatly. The depth of topsoil, the drainage, the dense layers, these things all cause differential rates of flow across the field. So it's not a flush of nitrate when you do get heavy rainfall. We've seen this chart before in the other presentations. So if you applied urea, which is going to convert to ammonium quite quickly in the soil, well, how long has it been in the soil? How warm's the soil been is going to determine how much of that is a nitrate. So if you just applied urea 3 days ago and had a heavy rain, the amount of nitrate leaching is going to be minimal because it hasn't had time to convert significantly to nitrate. So that's one factor. And of course, your soil characteristics, how fast or what's the infiltration rate of your soil texture. So sand's obviously over 2 inches per hour of rain, whereas clays can 0.2 or even less. And then what's your water holding capacity in a top foot? So you look at sands can only hold maybe 0.6 to 0.9 inches in the top foot, where clay can hold considerably more. So if it's been very dry prior to rain, the soil is going to take up some water before it becomes saturated, and then rain subsequent to that will cause some leaching to occur. So those are some of the factors to consider. So to monitor the remaining N supply, we often use the pre-side dress nitrate soil test. The results indicate both a nitrate and ammonium value, which is pretty critical to understand. Nitrates obviously are in a position to move, but ammonium is not. So that's going to convert eventually to nitrate. So it's good to know how much ammonium is left in the soil. The test does need interpretation. So if you happen to be doing the test in June, and for every pound of N you apply, it needs to be calibrated for the remainder of the season. So if you find, say, 100 pounds of N in June from the test, the slope of the response curve is 1.6, which means that 100 pounds of N in June is worth 160 pounds of N for the season. So those are some of the things to be thinking about, some of the things we can help you with interpreting should we need to apply more N because of leaching losses. These are some of the steps we'd go through. So thanks for listening. We'll be back tomorrow to talk about some other avenues of loss. Stay safe, stay healthy.